The Floyd-Warshall algorithm has a neat connection to finding the transitive closure of mathematical relations that I want to cover briefly. Consider a relation R over a set A, that is to say R is a subset of A cross A. For example, A might represent sports that one can watch on television, and the relation might be someone's viewing preferences. Maybe this individual prefers NBA to college basketball and NBA to college football, and we also know that he prefers college football to pro football. Since a relation is just a collection of ordered pairs, it makes sense to represent them as a directed graph. And given these preferences, we would like to be able to infer that this individual prefers the NBA over the NFL as well. In effect, if there's a path from one vertex to another, we'd like to add a direct edge between them. In set theory, this is called the transitive closure of a relation. Given what we know already, there's a fairly simple solution. Just give each edge weight 1, and then run Floyd-Warshall. The distance will be infinity if there's not a path, and it will be the minimum number of edges traversed otherwise. This is more information than we really need, however. We really just want to know whether there is a path, not how long it is. Hence, in this context, we use a slight variant where the entries in the table are all booleans, either 0 or 1 instead of integers. But otherwise, the algorithm is going to be essentially the same. We initialize the table so that the entry ij is 1 if aij is in the relation, and 0 otherwise. Note that I'm letting a1 through an be the set A here. Then we keep on adding potential intermediate elements and updating the table accordingly. Here, ij are in the relation if they're either in the relation already or if k acts as a link between them. Often we're interested not in the transitive closure of a relation, but in the reflexive transitive closure. In this case, we just set the diagonal elements to be 1 from the beginning here.